Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on January 29th, 2026, about 6 days ago. It challenges the idea that representation straightening is a universal mechanism for in-context learning, showing instead that large language models operate more like a Swiss Army knife, selecting different geometric strategies based on the task structure. The paper is titled, Context Structure Reshapes the Representational Geometry of Language Models. And as we'll see later, the specific breakdown of when models straighten their representations and when they don't is really illuminating. Figure 1 illustrates this core concept perfectly, using a visual metaphor. In the center, the model is depicted as a Swiss Army knife, implying it dynamically selects different computational tools based on the input. For continual prediction tasks like the grid world shown in the top row, the model uses a strategy where more context leads to straighter representations, as indicated by the higher red bar on the right. But for structured prediction tasks in the bottom row, like few-shot question answering, adding context actually results in less straightening, shown by the green bars. Well, Figure 2 details exactly how this straightening is measured and tested. The top panels define the metric mathematically, calculating how much the curvature of the sequence trajectory decreases as it moves through the transformer layers. The middle graphs validate this on text, showing that natural language, in red, straightens dramatically in layers 15 to 25, whereas random word sequences, in gray, do not. Finally, the bottom row presents the 4 experimental domains used to test the hypothesis, ranging from grid navigation to semantic riddles. So, Figure 3 zooms in on the continual prediction task using a synthetic grid world. Panel A outlines the setup, where the model learns the layout from random walks. The top row reveals a striking pattern. Unlike the short context in gray, the long context in red enables accurate prediction, which coincides with the massive spike in straightening shown in Panel Circa. Moving down, Panel G demonstrates that this is a progressive effect. As context grows, representations steadily straighten. Finally, Panel H plots the payoff, showing a near-perfect correlation between this geometric straightening and the model's actual behavioral performance. Alright, Figure 5 takes this a step further by testing if the model can learn a hidden structure. In Panel A, instead of seeing direct grid coordinates, the model only observes words like rain or forest emitted by invisible nodes. Panel B shows that with long context, the model correctly identifies neighbor words, and Panel C confirms this learning is driven by a spike in representational straightening. The critical test appears in Panel D, where certain connections are withheld so the model must infer them zero-shot. Remarkably, Panel F shows that straightening occurs even for these inferred transitions, proving the geometry captures the abstract latent graph. Figure 6 reveals a twist when we switch to structured few-shot learning tasks. Panel A breaks these interactions into 3 distinct phases: the question, the formatting transition, and the actual answer. Looking at the country capital task in Panel B, we see a fascinating dissociation. The transition phase in the middle, which is just repeating a template, straightens consistently as context grows. However, the answer phase on the right, where the real reasoning happens, stays flat, proving that representational straightening is not a universal law for all types of in-context learning. Okay, Figure 7 extends this analysis to naturalistic reasoning using the riddle benchmark. Panel A decomposes the task into 3 parts: the question containing the clues, the choice list, and the answer. Then Panel B compares the geometry between 0-shot and 8-shot performance. We see that the choice phase in the middle, which is mostly structural formatting, straightens out significantly. But crucially, the answer phase on the far right shows a sharp drop in straightening when context is added, confirming that the core reasoning process does not follow the same linear path. Wrapping up, 2 takeaways stand out. First, in context, learning is not a monolithic process. Instead, as the Swiss Army knife metaphor suggests, models dynamically switch strategies, straightening their geometry for prediction, but not for complex reasoning. This implies that we need a broader toolkit to understand how these models think. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.